Hi, today I'm going to show you how to solve the following problem using K-maps. Followings are the minimum sum of product that we need to solve. So I'll draw the K-map for this. So 1, 2, 3. 1, 2, 3. So let me name this as A, B, C, D. So this would be 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So I like to name this, so I'll make this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, now let's fill up the mean terms. So this is one mean term, 0, 1, 3, 5, 6, 7, 11, 12 and 14. Okay, so I'll put 0 everywhere else. Okay, so what do you mean by implicant? So implicant is like a single one or a group of one combined together on a map of function f to represent a product term is called an implicant. And a product term implement is a prime implement if it cannot be combined with another term to eliminate a variable. So okay, I'll show you how it looks. So let me draw this. So this is a combination of 4 prime implicant. So this prime implicant, this implicant and this implement cannot be this cannot be a prime implement. So it's a combination of 4. We have a bigger box of 4. So yeah, that's how it is. So this is 1, this is 1. You can make this pair as one implicant, this pair as one implicant. So yeah, and if a given midterm and all of the ones adjacent to it are covered in a single term, then that's called an essential prime implicant. So in this case, this is one essential prime implicant since this is included in only this box. This is one prime implicant since this is included in this box. This is not, because this is included in the bigger box and the smaller box. Similarly, this is not, this is not, this is not. This one is a prime implicant since this is only included in this one. So the one with stars are prime implicant, so even this one is a prime implicant. So accordingly, now we can write the function f, which is equal to a. So whatever is common, you should write that. So in this case, this is changing a bar, b bar, c bar for this one. So it's a bar, b bar, c bar. Similarly, for the block of 4, a bar is not changing here and d is also not changing here, so you should write a bar d, it remains same. So that's how it is. So then there is one more is so in this CD is remaining same, and A is changing, B bar is constant, so we can write B bar CD. Then similarly you can write A B D bar. This is the one I'm talking about. So it's A B D bar, and the last one is A bar BC. So this is how you solve the key map. So in this case we have a product of sum of max terms and a don't care term. Let's see how to solve this using key map. So I'll draw the key map for this. I write all the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and I'll write all the zeros and ones. So 5 is a 0 since it's a max term, 7 is a 0, 13, 14 and 15. Now let's write the don't care terms. This is don't care. So yeah, let's write A B C D 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. So this is one don't care. These 3 are don't care. 2 1 2 3. Yeah, so rest of the terms will be 1. So let me write 1. So now we have to find SOP. So this function will become, so we'll have to group the ones. If we were asked to find POS, then we would group zeros. So let's group the ones, the bigger groups. Let's start to make a bigger group. And yeah, so as we can see, the biggest group I can use don't care as 0 or 1, whichever minimize the SOP. So if I make this like this, this is a big one of ones which are of 8. So I'll make this all 1 and this all don't care terms 1. This could be a one more group, and this could be my third group, and my essential implicants would be this one. So as I told you, essential implicants are all the ones adjacent to it are covered by a single term. Then that mean term is a essential prime implicant. So this one is one of that. Then I can say of this one, which is covered by only this part, and this one is covered by the 8 terms. And yeah, and even this is also one of the essential prime implicants. So let's write the function for this. This would be, in this case, B bar is only which is constant. So rest of the variable are changing. So this could be B bar plus, and this, in this case, C bar D bar is there, and AB is changing from 0 0 to 1 1. So I'll write C bar D bar plus, the last one is A is common here, and D bar is common, so A bar, D bar. So this is the SOP for the following function. So let's see how to solve the following problem with Quinn-McCluskey method. So here you are given a mean term and a don't care terms, and you are told to find all the essential prime implicants and minimum sum of product. So in this case, we have to create a huge table that I'm going to create now. So let's say for each of the entries that we have, we'll divide it into groups where we'll count the number of ones and divide it accordingly. So in the first term, since the first one would be 0 1, since there is no 0 in this case, we'll avoid that. So we'll start with only 1 1. So 1, so this would be 0 0 0 1, and 4 has also only one in out of the 4 bits, so this would be 0 1 0 0. 4 is there in the don't care term, so we'll add that also. And 8 has 1 1, so this will become a group, first group. Let's go like that. We have to create a group for all the mean terms that we have. So since 3 has, now we'll go one step ahead and find out all which has 2 number of ones out of 4. So 3 has 2 number of 1, then 5 has 2 number of 1, 6 has 2 number of 1, 9 has 2 number of 1, 10 has 2 number of 1, 12 has 2 number of 1. Okay, and then we have 13, which has 3 number of 1. So this is my group 3 with 3 ones. So group, then 14 has 3 number of ones, and then 15 which comes in the group 4, which has 4 number of ones. Okay, so this is our first group. Now we'll look at group number 1 and 2. So let me name this as group 1 2 3 4. So now we'll look at group 1 and 2 and figure out if there are any pair of 1 which are adjacent. So how to figure out that 2 pairs are adjacent? So in this case, let's start with 1 and 3. They have adjacent pair of ones which will become 0 0. I'll add dash for the one that is changing and the one which is constant, 0 0 dash 1. So as you can see, 0 0 0 1 is common here, and here 0 1 is changing, so I'll write dash for that. So this is one adjacent pair. Then we can write 1 and 5. So 1 and 5 is also an adjacent pair, so let's write that like this. So 0 dash 0 1. So 0 0 0 0 1, this is there here, and same thing you can find here, 0 0 0 0 dash 0 1. So similarly I write for 1 comma 9, which will become dash 0 0 1. Okay, similarly let's write for 4 comma 5, So this will be 0 1 0 dash 4 comma 6 would be 0 1 dash 0 4 comma 12 will be 1 0 0 8 comma 9 will be 1 0 0 dash 8 comma 10 will be 1 0 dash 0 8 comma 12, which will be 1 dash 0 0. Okay, these are all the combinations that we can find. As you can see, 8 comma 6 cannot be, because there are two variable that is saying this is 1 0 and 1 0 0 1, this one and this one, this one and this one, and yeah, there are a lot of changing variables. So you can't have, you have only one change variable between the two groups. So group 1 and 2 should have only one changing variable, 2 and 3 should have the same, and 3 and 4. So let's write again for group between group 2 and group 3. So you can make 5 comma 13. 3 cannot be happen, 5 can be happen. So 5 comma 13 will be 1 0 1. 6 comma 14 will be 1 1 0. 9 comma 13 will be 1 dash 0 1, and 10 comma 14, this will be 1 dash 1 0, and 12 comma 13 would be 1 1 0 dash, and 12 comma 14 would be 1 1 dash 0. Okay, now let's do the final part. So between 13 14 15 we'll have two combinations, 13 15 14 15, both will work. 13 15 and 14 15, this is simple, 1 1 dash 1 triple 1 dash. Okay, so now we got two pair of ones. Now let's take this two group, let's say group 5 and 6, this would be 7. So in this two group which has the same 0 1, so I can see 1 5 and 9 13 will become one combination. So this both have 0 1 0 1, so this would be 1 5 9 13, and okay, now next one would be 0 1 0. So I'm looking for 1 9 double 0 1. I don't find any double 0 1 here, so I find 0 1 here. 4 5 and 12 13 have 1 0 common, so this would become one more, 4 5 12 13, this will be 1 0 1. Next would be 4 6 12 14, since 4 6 and this is common between 4 6, so this will become one pair. So this is something like this. then there is one is 8, 9, 12, 13, and one more is, this would be 1, 0, 0, 1 dash 0, and 8, 10, 12, 14. This would be 1 dash 00 dash. So this would be 8, 10, and 12, 14. So 8, 10, and 12, 14. Okay, so this becomes one group, and the final group would be between this and this. I can see only one combination: 12, 13, 14, 15. So this would be 12, 13, 14, 15. This will give me 1, 1 dash dash. Now let's see at all the combination of prime implicants and essential prime implicants. So as you can see, 1, 5 is here. You can find 1, 5 here. 1, 9 is found here. 4, 5 is here. 4, 6 is here. 4, 12 is inside this. 8, 9 is here. 8, 10 is here. 8, 12 is here. Similarly, 5, 13 you can find it in here. 5, 13 is here. 6, 14 is here. Well, 6, 14. Yeah, here. So this should be 14. Okay. Then 9, 13 is here. 10, 14 is here. 12, 13, and 12, 14. Okay. So this is how 1, 3 you cannot find anywhere. So this is one of the prime implicants. Similarly, these are all prime implicants. You cannot solve it further. So these are all prime implicants. So let's write down all the prime implicants. So prime implicants here is so 0, 0, 1 is A bar, B bar, D. Then AB is 1, A D bar, then A C bar, then B D bar, then B C bar, and C bar D. These are all prime implicants that we can find from this. Now let's map this on a graph. So it would be something like this. So this will become, let me draw it. So you should write down all the main terms that is there in the question. So in this question there is 1, 3, 1, and you should not write the don't care terms. So 1, 3, 5, 6, 8, 9, 12, 14, and 15. Okay, and let's write down all the implicants that we found here. So 1, 3 is A bar, B bar, D. Then 1, 5, 9, 13 is C bar, D. Then 4, 5, 12, 13 is BC bar. 4, 6, 12, 14 is BD bar. 8, 9, 12, 14 is AD bar, and 12, 13, 14, 15 is AB. Okay, so I just wrote all the min terms. You can ignore the don't care terms, and let's complete this. So this is let's write down 1, and since this here is 1 and 3, let's cross 1 and 3. 1, 5, 9, 13. Let's write across 1, 5, 9. Since there is no 13, it's a don't care term, you can avoid it. So 4 you can avoid. 5, let me draw lines. Okay, so it's 1, 5, 9 and 13 you can avoid. So 4, 5, 12, 13 you can avoid. Then 4, 6, then 6, 12, 14 and 8, 9, 12, 14. 8, 9, 12. Oh yeah, I made a mistake. This is 13, and there is one more term. 8, 10, 12, 14. This is AD bar, and 8, 9, 12, 13 is AC bar. Okay, yeah, so let me draw this lines also so that it's not confusing. Okay, now let's see. AC bar is 8, 9, 12, 13. So 8, 9, 12, 13, and this 8, 10, 12, 14 would be 8, 10 is don't care, 12, 14, and yeah, 12, 13, 14, 15 is last 3. Okay, so now let's find, so all the columns which has only one cross are all your essential prime implicants. So this is one cross, this is one cross, and this is one cross. So you got your 3 essential prime implicants. You can write that down. So I'll write a short form for that, ESP, essential prime implicant. This is AB, BD bar, A bar, B bar, D. Okay, now let's cross every So after this, what you have to do is you have to cross all the lines which has, suppose you have taken this 3 terms, cross all the horizontal lines. So you cross this, you cross this, cross all the rows which has the which you just wrote, this 3 lines, and then you cross all the x terms which is which you just marked, so in the column wise vector, in the column direction, so this direction, in the vertical direction. So you just cross this, so you just cross this, you cross this, so you cross this from here. So now what we are left with is this, and yeah, this. So we are left with 4 x terms, 1 2 3 4 6 x terms. So 1 2 3 4 5 6. So from this you can choose any 2. Let's say I choose c bar d. So I write here c bar d as a prime implicant, and if I do that, then my expression becomes, I'll cross this c bar d, I'll cross like this first, and then whatever it is included. So I'll cross this and this. If I had chosen something else, then my expression would be different. So now I am left with this choice, so AC bar. So AC bar would be my prime implicant, PI. Okay, so my answer would be F is equal to AB plus BD bar plus A bar B bar D plus C bar D plus AC bar. Okay, now if I had chosen something else, my function would have be changing. So if I had chosen let's say AC bar, if I had chosen this first, what would be my expression? I'll change the color of the line so that you can see it. So if I had chosen the EC bar first, so like this, then I would have crossed this, and my extra term would be C bar D. Okay, so yeah, that's how you solve Queen-Max-Lucey problem, and yeah, that's it for today.